Hello.
Hello, Mr. Eric. How are you? Good. Okay, so do you still remember what is factorial number?
Oh yeah, it's an exclamation mark.
Okay,
And you just
factorial.
times it
Can you tell me? Okay, what's factorial? If fi is a factorial number. Okay, so for example, 1 factorial equals what? 1 factorial. Exclamation mark. Yeah. 1. 2 factorial.
2,
3 factorial.
6,
4 factorial.
24,
5 factorial.
120.
Okay, so what are we doing here? Why is this?
We just times it 1 and then 1 times 2, then 1 times 2 times 3, then 1 times 3 times 4,
Okay.
then 1 times 3 times 5.
Okay, so
And
fi
then,
equals.
and then the next one is 720.
Okay, yeah. So fi equals I times I minus 1 times what? I minus 2
Until
what?
1.
Yeah. And we can say fi equals I times f what? Remember in the first day we talked about the recursion. Fi equals I times what? F what?
It's Fi subtract 1.
Yeah. So the f1, the terminal condition is f1 equals 1, right? Yeah. And f0 is also 1. So 0 factorial is also 1. Okay, this is a special case, yeah? Yeah? Okay, and 0 factorial is 1, 1 factorial, okay? Look, this is very important, okay? Okay, so now, if I want you to take, okay, so I erased a little bit too fast. So look, the first for you is 1, 2, 6, 24, 120.
720.
Okay. So, can you notice that if I have a factorial like 720, 200, 720, it's always bigger than the previous factorial sum, right? Right? Look, it's always bigger than 100 plus 20 plus 24 plus 6 plus 20. And 24 is always bigger than the previous sum, right? 120 is always bigger than the previous factorial sum, alright? 2 is bigger than previous sum. 6 is bigger than 1 plus 2, am I right? Yeah? Okay. Why is that? Look, we can prove this, okay? We can prove this. Fi plus 1 equals I plus 1 times Fi, right? Yeah? We already know that, right? Yeah? And this is bigger than I times Fi, right? Yeah? Look, Fi is a positive number times I plus 1 times. It's always bigger than times I times, am I right? Yeah? Okay? This one, okay. So I times Fi, what does it mean? Is equals to, there are, how many times of Fi?
How many?
I times Fi, how many times of Fi?
I.
Yeah, so that will be Fi plus Fi plus Fi plus.
Fi.
So there are I times of this, okay? I times this, right? Yeah? I times of this. Okay, so this, look, if I write it another way, look, the sum of the first I minus 1, okay, so the sum, okay, so let's say here we have this Fi plus Fi minus 1, right? Look, plus Fi minus 2 plus 2i. So this thing equals what? This is the sum of the first I items, right? Alright? So what we can use this, yeah? This is the sum. Sum Fj. J equals 1.
Sideways M.
Yeah, sideways M, yeah. So this is simple, is J equals 1 to I.
For a.
Okay, so you
W.
can think of it as a 4, yeah? 4 J equals 1 to I inclusive. And I want to sum Fj. So it's equals to Fi minus 1 plus Fi minus 2, right? Yeah? So there are I times of what? Actually, this is Fi. Okay. Yeah. This is Fi. Fj equals I to sum of Fi. So which one is bigger? This and this. Which one is bigger?
Which one?
Which one is bigger? This or this? Which one is bigger?
This or this?
Yeah. These I times and This one. Yeah, of course. Look, this is equal, but this is bigger than that. This is bigger than that, so it's bigger. And so what does it mean? So fi plus 1 is always bigger. This is bigger than the sum of its previous. Right? We just prove it. Yeah? Got it? Yeah? Okay, so remember this, okay? Remember this. This is very important in the thing we're going to talk now. Okay, so now, okay, let's write these first few again, okay? 1, 2, 6, 12. No. 6, 1. 24, 120, and 760, yeah?
No, 720.
Okay, 720. Okay, so if I give you a number like 31, can you represent as a sum of the distinct? What's distinct? Distinct. Distinct or unique, yeah?
It's distinct.
Distinct,
Like
unique. Unique.
dinosaurs.
Yeah.
Yeah, it's distinct.
31, can you represent as the sum of the factorial number? But each number you can only use one. That's what I mean, distinct. At most one.
24, 6, 1.
Wow, okay.
Oh yeah.
So yeah, you
yeah.
can. Then in this case, you can tell me yes. Okay, how about 4?
No,
Why is that?
you can't use 2 twice or use 1 4 times.
We are done. So, but this is not, yeah, because 2 we are using twice. Okay, another one is 144.
120 and 24. Oh yeah.
Well, okay. So how can you tell me so quickly? How can you tell me so quickly? What's your approach to do this?
So yeah, you know, but blah blah blah.
What? Sorry? How can you tell me so quickly? What's your approach to?
So.
Yeah? Come on, tell me.
You just subtract
Subtract what?
the things. Okay, so 31 is here, so you only can subtract these.
Yes. Subtract this. And so which number you need to try first?
The biggest.
The biggest, yeah.
Oh yeah.
And then you always take the biggest one if possible, yeah.
Yeah.
Okay.
If possible.
Can we do it from the smallest? Can we just take it from the smallest?
No.
Why is that?
Always you need, because it's a very small number, then you need to do it all.
No, look, take this 31 for example. Can you do it from the smallest? 1, 2, and what's next?
6,
6, and what's next?
24.
You can't put the 24, yeah? So you in this case it doesn't work. You risk the chance of
Hey,
using the bigger factorial, right? That's what it means, yeah? So we always take the biggest one, because if we can take this one, it means that we cannot. If you take this one, it means unique, because this sum is bigger. This is bigger than the previous
Yeah,
sum,
that's
yeah?
what I was about to
Okay, yeah, got it? So that works, yeah, because I take 24, I know the previous numbers cannot sum up to 24, yeah? Alright? But if you take the smallest number, like this, you risk the chance of using the 24, right? Because you already used the smaller numbers, am I right? Okay? Okay. We can also use the depth first search, right? Because look,
Yeah.
this is a kind of knapsack problem. Yeah, knapsack. What's knapsack?
Knapsack
Yeah, knapsack.
is a type of like sack that you nap in.
Knapsack is a bag, yeah, kind of bag. Okay, so look.
That you sleep in because it's
Yeah.
a nap sack.
Okay, 1,
Get it?
2, 6, 24.
Ah.
Okay, so these are the options, candidate, the numbers. And then each one we can choose pick or not pick, right?
Pick or not pick.
Yeah, if we pick it, we go to the next one. We have solved this problem before, yeah? So we want to take each item at most one. So for each item we can choose pick or not pick.
Pick or not pick.
Pick or not pick. And then we therefore search this until we get 31, okay? This is one approach. We can talk about this tomorrow, okay? But today we're going to implement this one. Yeah, implement this one. Okay, got it? Yeah? So in order to do this, what do we need to do at the beginning? In order to do this algorithm, what do we need to do?
We
Yeah.
need to.
What do we need to do? What are we doing here? We need to do what? What do we need to do here?
We need to do the ones which are smaller.
But yeah, what's smaller?
That we can subtract.
Okay, so but in order to do that, at the very beginning, what do we need to do? We need to
You need to.
calculate the factorial, right?
Oh,
Right?
yeah.
And obviously we need to put it in the list, yeah? And we can try from the largest. If we don't calculate it, it will be hard, right? We need to know these numbers, but that will be easier. Let's do this. Let's say define sum of factorial. Okay, factorial number and yeah. Okay.
Oh yeah. Oh yeah.
Okay. Look, let's put it factorial in nums. Yeah, in nums. At the beginning, what does it equal at the beginning? The numbers.
Zero. I mean list.
A list, a bracket. Yeah, list. Okay. At the beginning, fact. At the beginning is the first one is 1 and okay, and then we want to multiply by x. Yeah, x equals 1. Okay, so while fact is smaller or equal n, and what do we do? Fact equals what? Fact equals what? Fact times equals x. And then what should we do with the fact? What should we do with the fact? We put it in the list, yeah?
Yeah, with append.
So what? Can you tell me what's the right?
Append.
Nums dot append, come on. Nums dot append. Append what?
Fact.
And what's okay, and what's next? We append the fact, and what's next? What happened to x? X is
X plus 1.
x plus 1, okay.
Plus
X
equal 1.
So what? Yeah, x equals 1. Fact times 1 is 1, and we put 1 in the list, and then x equals 2, and we times f fact equals 2, right? Put the 2 in the list, and 2 times x plus 2 equals 1 is 3. 2 times 3, yeah, you got it? And I'll put it in the list, nums. Okay, now I want to start from the the largest one. So for I in range.
Wait.
What should I put here? There are 3 parameters. Start from the beginning. The rightmost element is what?
Minus 1.
Yeah, but what are we trying to do here? The nums here. The nums is 1, 2, 6, 24, 120. Yeah, look. That's nums. Nums array will be here. Will be this one. And what are we trying to do here? What should we try first?
We should try the biggest.
120. So what's the index of this? What's the index of this?
Minus 1.
What number? Why? What minus 1? Length. Length function num minus 1, and then at the end we want to go here, right? Right?
Yeah.
We want to reach here, yeah. But we need to give the one position to the left. What's the end?
Minus 1.
And then what's the step if you go to the left? What's the
Minus 1.
yeah?
Minus 1.
Huh?
Column.
Okay. Okay. If n is bigger or equal nums
Kapow!
I column, what should we do? If this number 120 is bigger than 120, what should we do? What should we do?
N.
What should we do?
Wait.
If we look before it's 144, right? If it now is 120, what should we do with this number?
We n minus nums.
N minus equals nums I. Okay, that's it. And then at the end, if you can't do it, if it goes through this already, and what should we check? If the number is 1.
If n equals 0.
Yeah, okay, let's what's the time complexity? It's very tricky, this one. What's the time complexity? What's the time complexity?
Oh.
Oh what? You can say oh anything.
Oh, anything.
Oh, let's say M, okay? What's M?
M.
Yeah.
M.
Yeah, what's the M?
M.
What's M?
I don't know, you made that up.
I made that up, yeah. M is, so what's the, here, what's this bit? What's the M? What's the
We
M?
have a for loop.
Yeah, so this bit, what's the M here? What's the M here?
Nums.
Nums. What's that nums? What's this nums?
Here.
Yeah, what's this nums?
Factorials.
The number of factorial that are small or bigger than n?
Yeah.
Small or bigger than n?
Smaller.
Yeah, okay, so m is the number of factorial that are smaller, that is smaller than n, right? Right? Yeah? If it's in this range, like 2 to the power of 31, right? If it's this 32-bit integer, if it's a sign, it's up to this, minus 1, yeah? So it's at most 12 factorial, distinct factorial. Yeah, we are excluding the 0 factorial. There are 12 distinct factorial that are smaller than this number. Yeah, okay. So if it is the case, we know it's the number is fixed. The time and space complexity is what? Oh, what? Come on. Oh, what?
1.
Oh, 1, yeah. Because I just told you if there are only 12. So here, at most 12 iteration. And here, almost 12 iteration. Okay, that's O1 in both space and complex times space complexity. But if I tell you n is arbitrarily large number, then you need to tell me OM, where m is the number of the factorials that is smaller. Yeah, that is smaller than n. Okay? Okay. That's it for today. Oh, that's it for today. You can say bye bye.
Goodbye, bye, bye, bye.